Now that we've looked at empirical probability, let's explore the connection between empirical probability and the other type of probability we can calculate, which is called a theoretical probability. The two types of probabilities are connected via the law of large numbers. So what the law of large numbers says is if an experiment is performed repeatedly, the empirical probability of a particular outcome more and more closely approximates a fixed number as the number of trials increases. Now remember, an empirical probability is the probability that is calculated as the result of an experiment. Okay, so what this is saying is as you perform this experiment, when you go to calculate this probability, those fractions that you're going to be getting, right? So the numerator is the number of successes, the denominator is the number of trials, and ultimately that fraction can be either expressed in a decimal or percent form. That probability that you'll be calculating will more and more closely approximate a fixed number as you perform the experiment over and over again. This fixed number is known as the theoretical probability. Okay, so I have linked right here an applet, so maybe we can kind of see what's going on. So I'll bring that up. And out of the applets, let's go to simulating the probability of a head with a fair coin. Okay, so when you flip a coin, two outcomes can happen. Either you're going to get a head or you're going to get a tail. So on this one, we're actually going to be able to simulate flipping a coin. So I told it to flip the coin once. And I got a tails. So up here, it's keeping track of how many times has head occurred. Well, it didn't. Out of one trial of the experiment. So this fraction 0 divided by 1 is 0, and so my probability is 0. Right? So I have the sample point down here. Let's flip the coin again. All right, so at this point in time now I have another tails. So I have had 0 heads out of 2 flips of the coin, and then my probability is still 0. So I notice it's still a line down here. Let's flip the coin again. All right, so now I got a head. So now out of 3 flips of the coin, I've gotten 1 head. So then that builds the fraction 1/3 or 0.3 repeating. Okay, so now I have this new sample point right here, and it went ahead and connected those for me. Flip the coin again. Oh, look, another heads. All right, so now out of 4 flips of a coin, I've gotten 2 heads. So my empirical probability of heads is 2/4 or as a decimal 0.5. Okay, so I got a new sample point right here. All right, so let's have it flip the coin 5 more times, so I'll get 9 trials total. Okay, so it's keeping track of whether or not a head happened out of the total number of trials. So every time this happens, notice that I'm building a new fraction, I'm getting a new probability, and then it's building a new sample point. Now what the law of large numbers says is if this experiment was performed repeatedly, this probability, which in this applet is being represented by this proportion over here, which is taking the number of successes divided by the number of trials, that probability should get closer and closer to a certain number. What number do you think that probability is going to get closer and closer to? So if I were to flip a coin, what do you think the chances are that I would have heads? Okay, well there's two possible outcomes, and one of them is heads. So then the argument can be made that the probability that the coin lands on heads is 1 out of 2 or 0.5. What the law of large numbers says is as this experiment would be repeated over and over again, this proportion should continue to hover around 0.5. So if right here I just click on 1,000 flips, okay, so it didn't actually all of the flips are over here if you wanted to go through all of them, but otherwise it just kept track of it for us. So it looks like then when I did this, I've now run the experiment 1,009 times. Out of that, I've gotten 500 heads or so in this simulation. So the proportion of heads is 0.4955. Notice it's really close to 0.5 or 1/2. Okay, so then as you can see here, this probability keeps hovering around this 1/2 line. And if I were to do this experiment another 1,000 times, again, notice that the proportion is still hovering around 1/2. So maybe to see this in a different context, let's take a look at rolling a die. Okay, so this is going to calculate the probability of us getting a 6. All right, so let's roll the die. Okay, so at this point in time, I have rolled the die once. I did not get a 6, so it did not improve my count. So the probability at this point in time in my experiment is 0 out of 1 or 0. Okay, so I got my sample point down here. At this point in time, this is still not a 6, so my probability is 0 out of 2 or still 0. Let's roll it 5 more times. So I got a 6, that improved my count. I got another 6 right here, that improved my count. Oh, and look, I got another 6. So at this point in time, I have gotten 3 6s out of 7 rolls of the dice. So then this ends up then at a empirical probability of 3 7s or 0.4286. So what the law of large numbers says is if I were to perform this experiment over and over and over again, this probability should approach a certain number. Now, what number do you think that the probability would approach? Well, we looked at the sample space out of a dice. There are 6 possible outcomes. If my event is rolling a 6, that outcome can be satisfied one way, right? Specifically, you got to get a 6. So there's one way that your event can occur out of the 6 possible outcomes. So then that fraction then would be 1/6, or as a decimal, 0.16 repeating. So what we think is then, as for the law of large numbers, if I were to perform this experiment repeatedly, this proportion over here should get closer and closer to what we would consider to be the theoretical probability. So now at this point in time, we've performed this experiment over 1,000 times. Out of that, we've gotten 148 rolls that were 6, so the proportion is 0.147. Okay, so notice that this is being kept track out here, and the 0.147 is right there. This green line right here is the fraction 1/6, okay, or as a decimal, 0.16. Okay, so notice that this empirical probability is really close to the theoretical probability. And then the idea is if I were to perform this experiment repeatedly and repeatedly, this probability should get closer and closer to that green line. All right, that's the law of large numbers.